Permutation. In this section, we're going to discuss about permutation, which is basically application of fundamental counting principle. We can use fundamental counting principle to count permutation, which we cover in last section. And we're going to use this notation, factorial expression notation. There is a formula to calculate the factorial, and there is a permutation formula. And there is another formula which calculates the permutation of duplicate items. Permutation means how many arrangement is possible where order matters. So permutation is an order arrangement of items that occurs when no item is used more than once. The order of arrangement makes a difference. So that's the permutation. Okay. So before we calculate the permutation, let's try to look at this factorial notation. N is a positive integer, then this notation is called n factorial, and the way we find n factorial is start from that integer and subtract 1 to the next and to the next and keep going until you get 1. So for example, if you want to find out the 5 factorial, then you start with the 5 and subtract 1 from that and subtract 1 from that and subtract 1 from that until you get 1, and then you multiply all of them. That's called factorial. This is 120. That's called 5 factorial. There is a special type of factorial, 0 factorial. The value is 1, and 1 factorial is also 1. So both of them give you the same thing. Now to understand the permutation, let's say there are 3 things, A, B, and C. How many different ways we can arrange them in order? So A, B, C, A, C, B, A. Now you can change the position of A. So B, A, C, B, C, A, C, A, B, C, B, A. 1, 2, 3, 4, 5, 6 different ways we can arrange A, B, and C. That's called permutation. So here's the formula. If you try to find the permutation of R items from n many items, then this is the formula you have to use. How many different type of group or permutation you can create? Let's say from 5 letters, but you want to create only 3 permutation of 3 letters choosing from 5 letters. So how do you calculate that? It's a 5 factorial divided by 5 minus 3 factorial. Remember, 5 factorial 5 minus 3 is 2 factorial, and 5 factorial means 5 times 4 times 3 times 2 factorial, and there is a 2 factorial on the bottom part. Cancel it. That's total 60. So there are 16 different ways to choose 3 items in different order from 5 different items. And if some of the items are repeated, for example, let's say there is a word, let's say B-O-O-K, book. How many words are there? 4. And then you can you can say how many, if we just rearrange them, how many different words we can make. It's a 4 factorial divided by, because this OO, they are repeated, that's a 2 factorial. That's all. So 4 times 3 times 2 factorial over 2 factorial. So there are 12 different ways to rearrange this B-O-O-K book. The one is O-B-O-K, another one is O-B-K-O, and then keep going like that. So there are 12 different ways. Okay, let's look at some examples. A permutation occurs when the order of arrangement does not matter. No, that's not correct. It does matter. So this statement is false. It should read a permutation occurs when the order of arrangement matters. That's the right statement. You need to arrange 5 of your favorite books along a small shelf. How many different ways? So the formula is how many different ways you can arrange 5 different books. It's a 5 factorial. 5 factorial. So you want to choose 5 from 5. So that means if you use this formula, it's 5 factorial divided by 5 minus 5 factorial, which is 5 factorial divided by 0 factorial, which is 1. So the answer is 5 factorial, which is 5 times 4 times 3 times 2 times 1, which is 120 different ways. So if you want to arrange 5 of your 5 books, then there are 120 different ways to arrange them. Okay. So let's calculate this factorial thing, factorial notation. How do you do that? According to the formula, on the top there is a 329 factorial, and on the bottom there is 328. So when you expand 329, it's actually 329 times 328 factorial. You can stop to the next number, and depending on what you have on the denominator, so you stop here. This is cancelled out, so the answer is 329. Basically, this is true for any number. If you take that number factorial on the top and one less number factorial on the bottom, then that would be the answer. What is how do you read it? The number of possible permutation of R items, which is 2 items, from 9 items. So what's the formula? The formula is choose 2 from 9 is 9 factorial divided by 9 minus 2, which is 7 factorial. So it's a 9 times 8 times 7 factorial, and there is a 7 factorial on the bottom part. So the answer is 72. In a race in which 12 automobiles are entered and there are no ties, in how many ways can the first 3? So choose 3 out of 12. So that's the formula. Choose 3 permutation out of 12, which is 12 factorial divided by 12 minus 3, which is 9 factorial. 12 times 11 times 10 times 9 factorial. You stop there because there is a 9 factorial on the bottom part. So 12 times 11 times 10 is 12 times 11 times 10. It's 1320 different ways. Let's look at the last problem. How many distinct permutation can be formed? So you want to rearrange these letters, and then you want to see how many different distinct permutation can be formed using this letter. So first of all, you have to calculate how many letters are used. 1 2 3 4 5 6 7 8 9 10. So according to this formula, this one, it's supposed to be 10 on the top, and then if you see anything is repeating, then you just have to so how many times it's repeating. So that's a 10 factorial. And then what is repeating? S and S repeating, so that's a 2 factorial. T and T is also repeating. No, S repeating 3 times. 1 2 3 times. T repeating 1 2 3 times. What else? T T T. I repeating 2 times. Okay, so that's the formula. So how many different ways you can arrange? Because there are repetition, So we just have to use this formula. 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. And then 3 factorial means 3 times 2 times 1, 3 times 2 times 1. 2 factorial is 2. So this 2 cancel out, this 3 cancel out. 2 times 2 is 4. This 2 and this 2 cancel out. 3 times 3 is 9. So the total number is 10 times 3 times 8 times 10 times 3 times 8 times 7 times 6 times 5. So it's a 50,400 different ways. 50,400 different ways. Okay, so that's all for this section.